Hi, my name is Brian Lee, and this is Team 9105's Eye Tracking Software Sprint 4. Our goal for the fourth sprint was to enhance our object detection prototype and meet the requirements for our two user stories. Our two user stories for this sprint were, as a user, I want to load the object detection plugin into Pupil Labs, and as a user, I want to use Pupil Labs gaze detection to collect data on objects. For the first user story, to load object detection into Pupil Labs, we decided that due to the proprietary nature of Pupil Labs software and the technical issues arising from manipulating their code, that it would be easier to create an independent plugin that would run using the information that would be fed from Pupil Labs. This seemed to be a more convenient and efficient method of integrating our code and reflected other eye tracking professionals' coding conventions. After deciding this first step, our next focus was then to use the gaze detection features of Pupil Labs glasses and derive meaningful insight through our plugin. This was accomplished in two stages. First, we were able to correctly map the data from the glasses software into our plugin. If you look at the video screen, you'll notice that the red marker on the laptop indicates the real-time gaze of the user. However, post-real-time, that red marker is placed directly into the video file, which does not allow us to access the information as an object. By exporting the XY coordinates of the red marker, we were able to recreate an instance of it, which can be seen as the green marker. This new instance, which is an overlay created by our plugin, can be interacted with by whoever is using our plugin, which allows for the data collection. Having created this green marker, our next step was to use the information. What we were able to accomplish in our plugin was creating a counter for the reference tracker. While we previously were able to draw a reference tracker, the frame in blue, we added a counter to track the number of frames the green marker crosses into the blue reference. Since the frames per second is consistent across all Pupil Labs hardware, counting frames allowed us to derive a standardized consistent measure for salience. For the video demonstration, we have highlighted the side view mirror of the car. Every time the user looks at the side view mirror, the counter begins measuring the number of frames the user has spent staring at that location. This can be helpful for user interface research when analyzing distractions while driving or other similar situations. We also accounted for edge case scenarios such as when an object moves out of the screen by allowing the plugin user to pause the video and redraw the object reference frame. A possible use of this feature would be to change the reference midway through the video from the side view mirror to a vehicle, for example. The next steps that we plan to follow in our Sprint 5 will be to refine the object detection plugin and to integrate the plugin with Pupil Labs software. Thank you so much for taking the time to listen to our video demo. This is Team 9105's Eye Tracking Software Sprint 4.